Well, today's lesson is a lot longer and the notes aren't too long, and then I'm just going to walk through a lot of the problems. So go ahead and copy this down. All right, so exponential and logarithmic equations. So we already know the exponential graph, right? Well, today we're going to talk about a logarithmic graph. Now, a logarithmic graph, if you look at this, if I take all of these points, this is the graph y equals 2 to the x, and I switch them around, and I graph 1, 0, 4, 2, 8, 3. That is actually the inverse graph, and that is a logarithmic graph, and that's reflected along the line y equals x. So that's what we're learning about today. So here we're going to add a logarithmic graph. So the logarithmic graph is going to be the inverse of this. So it's reflected along the line y equals x. All the points switch. So here we would have this as an asymptote. Now your y-axis is going to be the asymptote. And again, if this is the point 0, 1, well then this would be the point 1, 0. If this was the point 2, 4, oh, you guys can't see. Sorry. Okay, then this would be the point 4, 2. There. If this is the point 3, 8, then this is a point 8, 3. And again, why? Because 2 cubed is 8. 2 squared is 4. 2 to the 0 power is 1. And then this is the logarithmic graph. How do we write that? Log base 2 of x equals y, or y equals that. So remember how you can write something as a fraction and as a decimal, and it means the same thing. Like 1/2 is the same thing as 0.5. Those don't look the same, but one is a fraction, one is a decimal, right? Well, you're going to have the same thing for logarithms. You can either rewrite it in exponential form and logarithmic form. Like when you're doing math problems, what do you guys prefer? Fractions or decimals? Lots of times teachers prefer the fractions. You guys tend to use the decimals just because you can do them on your calculator. Well, same for us. What's going to be more natural to us? Something in exponential form or something in logarithmic form? You are going to have to memorize this formula right here. Logarithmic to exponential. Here's a quick example. And you can just remember how to the placing of the letters, or it's easier if you just kind of think about it. This is saying 2 is going to be your base number. So this is 2 to what power would give you 32? And I just remember it as you kind of say 2 to this equals this number. Somebody once was like, oh, it's like a little cycle. 2 to what power is 32? Okay, well, I can actually solve that. 2 to what power is 32? And we'll actually do more examples. A couple of properties listed in your book is the product property, and it says if you have two things that are being added with the same base, you can actually write it as a product. If you have two things that are being subtracted with the same base, you can actually write it as a division problem. This is probably the most important rule. It says if you have something to a power, you can actually bring that power in front, and then it lets you solve it. And I'll talk about that in a minute. This one is kind of neat. Also, if you have log base m equals log base n, and it's the same base, well, then you know that those two things are equal. This rule right here comes into play when you're solving equations. Well, they all do, but more so this rule. Recall when you guys were younger and to solve equations, and you don't have to write this part if you don't want to. To undo addition, you subtract, right? To undo subtraction, you add. To undo multiplication, you divide. To undo division, you multiply. To undo multiply by a fraction, you would multiply by the reciprocal of your fraction. To undo a, what did you guys learn next? Like an x squared, you can actually square root it, you can factor it, you can complete the square, you can quadratic formula it, a bunch of things. X cubed, same thing, you do the third root of it, and there's some also special factoring, different things. All right, so now what we're doing is we're gonna have some number to the x power. How do you get rid of a variable exponent? If it was to the fifth power, you fifth root both sides. You can't x root something, so how do you do it? That's where logarithms come in. And so that's the point of this unit, and that's what we're working towards. This is the end of your new units, of your notes for today, but I'm going to continue on and actually walk you through the homework problems. All right, so we're going to start on homework, and we're actually going to do 20 through 52 all. So this is going to take us some time. I copied down the first section. So homework 11.4, page 723, 20 through 52 all. Go ahead and pause the video, copy this down, and then come back and we'll go through this. Okay, so the first problems say write in exponential form. Well, I can see that it is in logarithmic form, so I'm changing it from logarithmic to exponential. So to change that, you're going to take your base number, 27 to the 1/3 equals 3. That's it. You're done. If you wanted to do more with this, you know that 27 to the 1/3 is actually the same thing as the third root of 27. Third root of 27 is 3, and that's why they wrote it that way. But this is all that they want. Okay, next one. 16 base to the 1/2 equals 4. And again, why does that work? Because that is 16 to the 1/2 is the same thing as the square root of 16 equals 4. 7 to the -4 equals, okay, why does that work? Oh, what does a negative do to the bottom? Oh, it bumps it down to the denominator. And I don't know what 7 to the 4th is, but it's probably that number. And you should have a table of values. All right. 7 to the 4th is 2,401, and when it's negative, it just gets bumped on the bottom. Okay, try this one. Your base number is 4. Your exponent is 5/2. And your answer is 32. And again, if you wanted to understand this problem, this is going to say this is a square root of 4 to the 5th power. Square root of 4 is 2. 2 to the 5th is 32. All right, next one. Oh, so I actually did I copy this right? Oh, this is a little e right there. So your base is e. Again, what is e? E is not a variable. E is a number. It's about 2.7. So this is e to the x equals 65.98. So they're saying e to what power will give you this. And we're not solving this one yet. We're just rewriting it. I think in the next section they're solving them. Change this one again. So this is your base number raised to this power equals 36. And again, how does this make sense? Well, remember that square root of 6 is the same thing as 6 to the 1/2. And if you were to multiply that to the 4th power, that's 6 to the 4 halves. So 6 squared is 36. Okay, they only wanted you to rewrite it, but again, that's why the math works. Okay, the next section is write each equation in logarithmic form. So now we're changing it from exponential to logarithmic. So I'm going to go ahead and copy those down. So go ahead and copy the next problems down. It's write each equation in logarithmic form. You can hit pause and copy them down. All right, so now I'm going to go back and I'm changing it from exponential to logarithmic form. So the only thing I need to remember about that is log, your base is still always your base number. So 8136, it's always your base number. So that's 81. And then your exponent is going to be over here. So on this side, and your answer is here. So it's log 81.9. And then you're going to do the same thing for the other one. So if you were to rewrite it, it's 81 to the 1/2 equals 9. So log base 36. Your power goes to the other side and equals 216 here equals 3/2. Same thing here. Log base is 1/8. Your exponent's going on this side, so 512 goes here to the -3. Log base 6, 136 goes here. And I'm not sure if I ever told you how to read this. You read this log base 6 of 136 equals -2. If there's no number here, it's an implied base 10, and you can also have base E as well. So log base 16 equals 0. Do this one on your own. Ooh, what's your base? X. Log base X. Okay. All right. Oh, and excuse the dirty fingers. I've been working with my husband at his mechanic shop. All right, next. All right, so our next section is going to be evaluate each expression. These two parts we're just rewriting from exponential to logarithmic and backwards. This is probably the most important, and then you need this idea to actually go to solving equations. So I'm going to go ahead and copy those. Okay, so take a minute, copy all of that down, and you only need about maybe 2 spaces. It's probably just 1 line space in between, but if you left 2 spaces, it'll be a little bit neater. All right, pause the video and then copy all this down and come back. All right, evaluating the expression. Evaluating the expression says, tell me what this answer is. Well, I have to change it. Some of you don't have to change. You can just think about it. I always write an equation that just makes the most sense to me. So I'm going to say this is equal to y or x. I'll just say x. And then I'm going to change it from logarithmic to exponential. 8 to the x equals 64. Oh, well then that's a lot easier for me to see. 8 to what power is 64? Oh, x is equal to 2. 125. So again, you can think about it. Again, I just like to set up an equation. So 125 to the x power is equal to 5. So this one's a little bit weird because how do you go from 125 to 5? Okay, so we were saying, how do you go from 125 to 5 when it's raised to the power? It has to get bigger. The only way to get smaller is to take like a square root or something. So I'm going to go here. So 125, if you take, you can see it here, the third root of 125, you would get 5. So 125, well, the third root of 125 is 5. How do I write that for x? So x would have to equal 1/3. Okay, so easy. This one a little bit tricky. Next one, same thing, set it equal to x. 2 to what power is 32? Good. So again, if you didn't know that, you could see 2 to the 5th power is going to be your 32 right there. 2 raised to the 5th power is 32. So x is equal to 5. All right, the next one. 4 to what power is going to give you 128? So remember how I was looking for 2 to what power gives you 32? So I'm now looking at here, 4 to what power gives you 128? 4 to no whole number power will give you 128. So there's only one other way. Well, you could always guess and check. Well, let's just rewrite it first. So this is okay, so that didn't help me. I'm going to go back to your notes. And there is one rule that I'm not sure if I saw it in your notes. I'm going to add something. It is called a change of base. Let me write this down. Go ahead and add this to your notes. It says change of base. If you have something like this, 4 to some power is 128, you could actually solve it by just taking the log of 128 and dividing it by log of 4. So log of 128 divided by log 4. And I got 3.5. So I'm going to see if that's actually right. 4 raised to the 3.5. It is 128. All right. That's a change of base. And that's only if it wasn't on your table, if it didn't come out exact. Or if it actually works for the other ones as well, if you didn't know it. I'm going to take this and write this down here. So let's just say I wanted to do the change of base for this one. I would have done log 32 divided by log 2. Where's my log? Log 32 divided by log 2. And it also tells me the answer. Why didn't I just tell you to do that here? Well, because this problem, you would know it. It's quick. 2 to what power is 32? This one, not so fast, so then you would want to use the change of base. All right, so we're going to add that. Okay. All right, now let's go back to this one. This looks weird. Log base 9 of 9 to the 6th. So set up an equation. And again, I always set up an equation. Some of you might be just doing this in your head. That's fine. So 9 to some power equals 9 to the 6th. Well, look at this. If you have 9 to some power equals 9 to the 6th, well, then those two things have to be equal. So x has to equal 6. All right, next one. Rewriting this one again. So 49 to the x equals 343. Oh, this might be an interesting one. This is a good one. So for this one, the first thing that I think of is 7. I know 49 is 7 squared, and I think 343 is a power of 7. So I look here and I go, okay, I know 7 squared is 49 and 7 cubed is 343. So I'm going to rewrite this way as 7 squared x equals 7 cubed. Well, if 7 to the 2x is equal to 7 cubed, well, then you know that these two things have to be equal. So 2x is equal to 3. Solve for x. X is equal to 3 over 2. So x is equal to 1.5. Now that's how I would have done it. Now some of you might have said, wait, if I didn't know that, I should have just done it this way. I could have used the change of base rule that says log of 343 divided by log of 49. The same thing I did over here. And if you would have done that, it still gives you 1.5. This is kind of neat because sometimes they do problems like that where they have the same base, or you can rewrite it in terms of the same base. So this will work, but if you can rewrite it with the same base, that's kind of neat as well. All right, moving along. Again, long lesson. Set it equal to y, or x. 8 to the x equals 16. Well, this one's easy. 8 squared. So, oh, wait. 8 to what power is going to give you 16? Oh, that's another trick one. So we can do it the same way, although this one's a little bit tricky. Well, first let's do the change of base. We could do that first. And then we see what base do you want to use. Now, normally I would think of base 4, but 4 to what power gives you 8? It doesn't. So you have to use what base? 2. All right, so let's try that. So if we did it the same way as this problem over here, again, our common base is going to be 2. So 2 to what power gives you 8? 2 to what power gives you 16? So if 2 to this power is equal to 2 to this power, then we know that those two powers are equal. Do your math and solve. So x is equal to 1 1/3. And again, I could test it out and say, make sure 8 to the 4/3. Okay, so that's right. Now, if I didn't do it this way, I could have done the change of base. So change of base, do you guys remember what that is? Log 16 divided by log 8. So log 16, oops, let me clear it. Okay, yep, 1 1/3, same thing. All right, okay, try, oh, this one's a weird one. So let's go to this one. Equals x. So this is a square root of 8 to the x power is. Now this one, oh, I want to see a common base. Let's see. So for this one, I know that this is the same thing as 8 to the 1/2. So I'm going to rewrite this as 8 to the 1/2 x. 4096, I don't really know what that is, so I'm going to look here and I'm going to try to find 4096. 4 to the 6th power gives me 4096. I also see that 8 to the 4th power gives me a 4096. In this case, because my problem is 8, I'm going to pick this one, 8 to the 4th power, and rewrite it that way. Okay. So I'm going to say 8 to the 4th power. So now this is the same thing as x over 2. 8 to that power is equal to 8 to that power, so we know those two powers are equal. So x over 2 equals 4. Multiply both sides by 2. My answer is 8. And I could always check it. Square root of 8 to the 8th power is that. Change of base. If I quickly did the change of base, that is going to be log of 4096 divided by log square root of 8. Common mistake is that students think it's 4096 divided by square root of 8 and the log of that. It's not. It's log of this number and divided by the log of this number. You have to have two logs in there. Otherwise, you'll get the wrong answer. So plugging it into my calculator, and I get log 4096 divided by log square root of 8. Okay, so it actually checks. And if I did square root of 8 outside, let's see, to check it, I would get 4096. Okay, so again, you can always check your work. Number 40 is a weird one where the property doesn't actually imply how you would simplify this. And what you have is, so if you don't get this one, not a big deal. This is a weird one. What they have is, because this is 10 raised to the log base 10, you still have a 4 and a 2 here. They actually cancel these out and they leave it as 4 squared, which is 16. I don't have a really good way of explaining that one. It's just like it's just, I guess, a rule that they would have, but it's not very clear. So anyways, this one is just 16. Don't worry about that one. Okay. Next ones are solving each equation. And so this is the whole point of this unit, is to solve logarithmic equations. Because again, you already know how to solve all of these types of problems. Now what you're learning is how to solve log equations. And there's actually probably 4 different methods that you can use to solve this. So remember when we did solving quadratics, we did square rooting, factoring, quadratic formula, complete the square. There's probably about 4 methods here, and teaching it online is a little bit long and confusing. So I'm just going to kind of work through the problems and hopefully you kind of get it from there. And maybe for next time I'll try to do a summary or something like that. So let me copy these problems down. Okay, so here we go, the last set of problems. I wouldn't copy them all down because you don't know how much room they're going to take. Some are fast and some are take longer. So let's just do one by one. So 41, log base x of 49 equals 2. So what method do we know? Oh, okay, let me rewrite this. This is x squared equals 49. Changing it from logarithmic to exponential. Well, what number squared is 49? Correct. So x is equal to 7. And again, you could take your answer and plug it in and check it. All right, now let's look at this one. Log base 3 of 3x equals log base 3 of 36. Well, you notice how you have these two. Log base 3 of that is equal to log base 3 of that. So what can you say? Yeah, that this one has to equal this. And then from there, do your math and solve. This problem is way too long. So what you want to do is you want to go back to your notes and you say, okay, what can I do to simplify this? Well, here we have an addition. So to simplify addition, you can make it a multiplication. You keep your base and then you multiply those two. So this is log base 6 x times 9. I'm just going to write it as 9x equals. Okay, so now this problem turns into this problem here. Log base 6 of 9x equals log base 6 of 54. Well, then you know that this has to equal this. divide by 9. So x is equal to 6. All right. Next one, number 44. Copy that down. And I cannot read my writing. What is that? 44. Oh, that is a W. Log base 8 of 48 minus log base 8 of W equals log base 8 of 6. Okay, so this problem is still too long, so I'm going to go back to my notes and say, okay, subtraction. I can change every subtraction problem into a division problem, so I'm going to go with that. So now that I've changed that, log base 8 of this equals log base 8 of 6. So I know that this is equal to this. So I'm going to set those two equal to each other. And then how do you solve that? You have to get your W up in the numerator, not in the denominator. So multiply by W on both sides. You could also cross multiply. So you get 48 is equal to 6W, divide by 6. W is equal to 8. Can you see that? Okay. All right, doing good. It takes you longer to write the problem than to solve. All right, next one. Here we go. This one, log base 6 of 216 is equal to x. So 6 to the x is 216. You either know what that is, or you can go back and look at your table, and that is 3. So looking for 6 to what power gives me 216? It is 3. Again, if you didn't know that, change of base. So change of base would always work for this one. Do you guys remember that? That would be log 216 divided by, not 6, by log 6. Let's set up my calculator. So log of 216 divided by log 6. Okay, and it's 3. Because if you did log 216 divided by 3, or divided by 6, it's a different answer. Okay, so that's wrong. It's log and then log. All right. Go ahead, try this one on your own. Rewriting this. Pause the video and then come back and check your answer. So you rewrote it. Did you get the answer? Okay, so mathematically, let's see. I know that this is the same thing as, I know these two are kind of related. So if you know the conversion, that's fine. If not, you do know that this is 4 100ths. Well, 4 100ths reduces to 1 over 25. So let's look at this problem. Okay, this is the same as this. How do you get from 5 to 25? Well, that's easy. It's squared. 5 squared is 25. But how do you get it in the denominator? To get something in the denominator, you have to make a negative exponent. So 5 to the negative 2 will give you 1/25, because this would be 1 over 5 squared, which is 1/25. So your answer is -2. Now, if you didn't see that, then you can do the change of base. And that's why the change of base is actually really useful, because you can just say the log of 0.04 divided by the log of 5 is, so plugging it into my calculator, divided by log 5, -2. All right, almost done. 2 more problems. Oh gosh, no. Four more. Wait, we still have we have a lot more problems. Never mind. Okay, keep going. Let me work a little bit faster. Again, I would copy them as you go so you know how much space to leave. Don't copy them ahead of time. All right, let's do this one. So 47 log base 10. Well, you can see it. Okay, I'm going to rewrite it. 10 to the x equals. This is the same thing as 10 to the 1/3. So x is equal to 1/3, rewriting it from square root to a fraction. This is way too long, and this is a really good test problem. So what you're going to do here, first, this is addition, and I go back to my rules, and I know that addition I can rewrite as multiplication. This is only part that's tricky is right here. You see this number in front? You can actually change it and raise it up to that exponent. So we haven't used the power rule, but just like you can bring the exponent down in front, you can bring it back up the other way. So I'm going to change that. Too thick. Okay. 9 to the 1/2 is the same thing as the square root of 9. So square root of 9 is just 3. 27 to the 1/3 is the same thing as the third root of 27. Third root of 27 is just 3. This is addition, same base, so I know my addition rule says that I can actually multiply them. So this is log base 12, 3 times 3, and then I'm going to bring this down. Log base 12 of x equals log base 12 of 9. Well, if you have the log of those things, then you know that those two have to be equal. So x has to equal 9. Okay, that was a tricky problem, just condensing it. That's called condensing it, putting it all together. All right, this one's going to also be ugly. This is way too long. Again, addition says that I can change my problem from addition to multiplication. So I'm going to combine this. So, and this is I could have written the 8 back here. I just put it in front because I know I'm going to have to distribute. Well, do I? Actually, if I have log base 5 of this and log base 5 of that, what do I know? That this is equal to that. So actually, I don't have to distribute. I could, but I'm just going to leave it and then solve it this way. So your whole point is to get rid of the logarithms and just get an equations to kind of solve. So x is equal to 4. All right, number 50, same thing. Here we have these. Ooh, this is not going to be a nice one. This is a quadratic. Okay, so here we have an addition. So we're going to multiply these two. Gonna clean this up a little bit. Log 4, and this is just FOIL. So combine your like terms, you get x squared minus 9 equals 2. I'm stuck here now because I have a logarithm here, not on this side. So once you only have a log on one side, you can change it from logarithmic to exponential. So 4 squared equals x squared minus 9. then to undo the square. All right, so real quick, 4 squared is 16, not 8. I'm sure some of you guys caught that. Thank you. No one gets extra credit though. 16 plus 9, 25. And x squared, to undo that, you square root it. And the logarithmic, we're just going to take the 5. So x is equal to 5. All right. All right, now we only have 2 more to go. So the first thing you want to do is clean it up, make it simpler. So let's see, what can we do first? Well, here I have addition, so I'm going to combine those. So that is 1/2 8x The next thing I'm going to do is I have to get rid of that number. So I think I'm going to raise it back up to the front. That is going to be the square root. All right, so then I have this. Now, if I didn't have this, this would be nice because I could set 8x equal to 16, but I have this. So I want to get rid of the log, so I need to isolate these two so that they can set equal to each other. So I'm going to raise this exponent back up here. So this is now, and that's using this property that you can raise the exponent back up or down. Okay, so now I have log base 7 of this equals log base 7 of this. So what do I know? That those two things are equal to each other. So I can set those two equal. So 8x to the 1/2 equals 16. This is the same thing as square root of 8x, but I don't like that. So how do I solve that? How do I get rid of that? Raise it to the second power. So that cancels. We're left with 8x. 16 squared, using my calculator, is 256. Okay, now it's nice. 256 divided by 8 is 32. This was a tricky one. And again, why? Because you're using all of your rules and you have to know when to use which one. And that can be a little bit confusing. All right, so 52, what are your thoughts on this one? Copy it down. Real quick, if you didn't not have the same base, this would not work. If you had like a base 7 and a base 9, you could not do this. They have to be the same base. So when you look at your problems, that's why they're always written with the same base so that you can apply this. So first thing we're going to do is bring that exponent back up. So that's going to be okay. Log base 5 of this equals log base 5 of that, which is nice. So now I know I can set this equal to this. Some people say they cancel. They don't really cancel. It's just that you're setting this piece equal to this. All right, and then to solve this, you can actually multiply this out or just square root. So we'll go ahead and square root this. Now, usually you take the positive negative, but the logarithmic, you're going to just take that positive one. So it is x minus 2 equals 6. Add 2 to both sides. All right, and you're done. Okay, now that's it for homework and notes. A lot of stuff. Okay, thanks.